Welcome back everyone. Today's session we are going to continue exercise 7.1, question number 9 and 10. In the previous sessions we have seen the meaning of equidistant and we solved a question based on that. So again we have got a question in which q of 0, 1 is equidistant from p 5, minus 3 and r x, 6. Okay. So what is the meaning of equidistant? I already said you that. Let's again recall that concept. So suppose there are two points, say point P is here and point R is somewhere here. Point P is nothing but 5, minus 3 and point R is nothing but x, 6. So these 2 points, these 2 can be locations, any 2 locations on a graph, on a map. These 2 are equidistant from q of 0, 1. So according to the previous concept, what we can say in this? I can say that distance PQ is equals to RQ. Sorry. So I can say that when P and R are equidistant from Q, I can say that distance PQ is equals to QR. So proceeding with this, since Q is equidistant from P and R, okay, Q is equidistant from P and R, QP is equals to QR. Now we have to find the value of x. So you can see in this R there is one coordinate, x coordinate. So we have to find the missing coordinate x when these 2 are equal. Okay, imagine this P and R are 2 locations, they are equidistant from Q. So you need to find exact position of R. So we'll use distance formula here again, finding QP. Okay, we'll find distance QP and we'll find distance QR and equate them. Okay, so from Q and P I have taken x1, y1. What is our Q? 0, 1. So x1, y1 is 0 and 1. x2, y2 is 5, minus 3, because we are taking Q and P. I am finding the distance QP. So I am taking the points Q and P. So what is the point P? P is 5, minus 3. So this will be your x1, y1 and x2, y2. 5, minus 3. If I proceed with this and find the distance using the distance formula, let's find the distance. So x2 minus x1, 5 minus 0 whole square plus minus 3 minus 1 whole square. 5 minus 0 is 5 whole square and minus 3 minus 1 is minus 4 whole square. So that becomes 25 plus 16. Okay, and that will be root 41. So distance PQ is root 41. Then next we'll find, similarly we'll find distance QR. So for Q and R, x1, y1 will be 0, 1 and x2, y2 will be x, 6, because the coordinates of R are x, 6. You can clearly see here. Okay, x, 6. So coordinates of x2, y2 are x, 6. Again I'll find the distance QR. Okay, so we'll find the distance QR here by using the same formula. So x minus 0 whole square, x2 minus x1, and y2 minus y1 is 6 minus 1 whole square. So x minus 0 is x whole square, plus 5 square is 25. Finally we got the distance QR as 25. Now I can equate this both the distances. I can equate QP and QR because they are equidistant from. So we'll equate these two distances QP and QR and try to find the value of x. So we have done this. Now next part is, just I'll write it here, we have to find, after finding the value of x, so we are going to equate these two and find the value of x. Okay, we'll equate this both and we'll find the value of x. After finding x, he's asking you to find the distance QR and PR also. So he's asking you to find the distance QR and PR, both the distances. So we'll first find the value of x. Let's proceed with it. So we are equating this QP and QR, which we got just now. Root 41 and under root x square plus 25. Squaring on both the sides. To remove the square root, we'll cancel square and root. 41 is equals to x square plus 25, and 41 comes to the right, it becomes x square plus 25 minus 41 and x square minus 16. So x square is equals to 16. X square is equals to 16. So x is equals to under root 16. Okay, and under root 16 can be plus or minus 4. I said you this before also. Under root 4 square or under root minus 4 whole square. What will be the answer for both of this? Both will give you under root 16, isn't it? So that is the reason we say the root of 16 can be plus or minus 4. Okay, we'll not take this in every problem. Root 16 plus or minus 4 is taken in few cases where it is possible. So here it is the graph, the case of graph in coordinate geometry. So the value of x can be positive, it can be negative also. We cannot take root 16 as 4 when we solve the questions of age of father and son, or distance, speed and time, because those all cannot be negative. Okay, so x is equals to 4 or x is equals to minus 4. So finally we have got our point R. Yes, this point R we have got. What is R? It was x comma 6 given. Now what is the value of R? X comma 6. The value of x is 4 or minus 4. So we have got the value of x as 4 or minus 4. Now we have got two cases. Okay, we have got two cases. If I take this figure, for this R we have two possible cases. R can be 4 comma 6 or R can be minus 4 comma 6. Okay, it takes two values. Now let's proceed. We have to find QR and PR. Okay, we have to find QR is this distance and PR means this distance. Okay, so let's proceed with this and find the distances QR and PR. We need to find the distance PR and QR. Finding QR first. So already we found QR till x square plus 25. Okay, in the first case we found QR till x square plus 25. The same thing we can use for finding QR. So if I take x is equals to 4, then QR will be x square. What are the two values we have got? We got two values of x. So we'll substitute both the values in this. We'll get two cases. So x square plus 25, x square 4 square plus 25, 16 plus 25, 41. And if I take this minus 4 also, I get root 41. So you should show both the cases. Hence QR is root 41. Then we'll find PR. He is asking you to find PR, okay, PQ and QR. So here we have PQ and R like this. So we found QR. Now he is asking you to find PR. This distance he is asking, okay, keep it in mind. He is asking you PR. He is not asking you PQ, because PQ is already root 41. Okay, you can observe here PQ is already, we already found that PQ, that is root 41, and now we have to find, this is root 41. Okay, we don't have to find this distance, PR. So finding PR, here also we get two cases. Okay, the first we'll find PR with x comma 6. What are the coordinates of P? Coordinates of P you can see here 5 comma minus 3. Coordinates of P are 5 comma minus 3, and coordinates of R are x comma 6. Okay, the 5 comma minus 3 is your x1 y1, and I am finding which distance now, just keep it in mind, this distance I am finding now. Okay, PR. So 5 comma minus 3 is your x1 y1, x comma 6 is your x2 y2. So we'll find PR distance by taking x as x only. Okay, x minus x2 minus x1, so x minus 5 whole square, and y2 minus y1 is 6 minus of minus 3 whole square. If I proceed with this, finally I'll get x minus 5 whole square plus 9 whole square. Now again we have two values of x, so we can substitute both these values, x is equals to 4 and minus 4, for finding PR also. After substituting x is equals to 4, I got root 82 and root 162 here. So these problems looks quite lengthy, but if you understand the concept, they are very simple, and these all are the basics of coordinate geometry. Still you are learning. Okay, I said you that you will be learning the next levels of this in your higher classes again. Okay, so this is the way we find the value of x and the required distances. Next, the last question of the exercise. So with this we'll finish the exercise of 7.1 in which we were using distance formula. After this we'll jump to exercise 7.2 in which we use a new formula, okay, a new concept. But before going for that, you need a lot of practice for the concepts of exercise 7.1. Now we'll see the question number 10 of exercise 7.1, and this is the last question. So find a relation between x and y such that the point x comma y is equidistant from the point 3 comma 6 and minus 3 comma 4. Okay, so here also the term equidistant is given. So we have to find relationship between x and y. X comma y is equidistant from 3 comma 6 and minus 3 comma 4. When, so we'll take, let the points be a x comma y, b 3 comma 6 and c minus 3 comma 4. So according to the question, point A is equidistant from b and c. Okay, x comma y is equidistant from b and c, so I can say AB is equals to AC. So we'll find AB and AC using distance formula. Okay, we'll find these two distances. So first we'll find AB and AC, okay, in this way by applying the distance formula. So here if I show you with the diagram again, it's given that, again I'll draw two lines, these are on the graph. So which point comes here, which point comes in this question mark? Relation between x and y such that point x comma y is equidistant from 3 comma 6 minus 3 comma 4. So here comes x comma y. What comes here? X comma y. And here comes 3 comma 6 and minus 3 comma minus 3 comma 4. Okay, so I named them as A. What did I name it as? I named it as A. For this one I'll use another color. So we named it as A, and this is your B, and this is your C. So if you look at this diagram, you can say that point A x comma y is equidistant from 3 comma 6 and minus 3 comma 4. So what will be equal in this case? AB is equals to AC or not? Yes, AB is equals to AC. So that is the reason we are finding AB and AC by using distance formula. Okay, so you have to do it very carefully. You can draw the diagram in the rough column for your understanding. AB, so when you find distance AB, x1 y1, so you should focus on A and B only, just leave the C coordinate C. So x1 y1 will be xy and x2 y2 will be 3 and 6. Substituting in the formula, we get 3 minus x whole square, x2 minus x1, and 6 minus y whole square, y2 minus y1. Then we'll find AC. This distance also we'll find in the same way. So here x1 y1 is x comma y and x2 y2 is minus 3 comma 4. Substituting this also in the formula, minus 3 x2 minus x1 is minus 3 minus 6, and y2 minus y1 is 4 minus y whole square. So this way we found the distance. We'll not expand this further, we'll equate these two. Now why we should equate these two? Because distance AB is equals to AC. So let's equate this both and try to find the relation. So I'm equating both AB and AC, squaring on both the sides so that I can cancel square and root here. Square and root gets cancelled here and here. So remains 3 minus x whole square plus 6 minus y whole square here, and here remains minus 3 minus x whole square plus 4 minus y whole square. Okay, simplifying it by using a minus b whole square, a minus b whole square. Here also I'll use a minus b whole square. So I'm using a minus b whole square identity in and expanding all these. So when you expand, you will get first one. If I expand this one, I'll get these 3 steps with first one, and if I expand the second one, we'll get these 3 steps, these 3 terms, 6 square plus y square minus 12y a square. Which formula we are using here? A minus b whole square. Okay, which you have done. A square plus b square minus 2ab. This is the formula used. And for the next one, right hand side, minus 3 minus x, so we'll get these 3 terms. And the last one, what is the last one? The last one is 4 minus y, so we get these 3 terms. When I expand this all, we'll get the next step. Then I'll take all the terms to the right or all the terms to the left. So transposing all the terms on one side. Okay, we'll transpose all the terms on one side, so we'll get this step. Simplifying it further, this gets cancelled. X square minus x square gets cancelled here. Minus 6 becomes minus 12, and y square also gets cancelled, and minus 12 plus 8 becomes minus 4y. 9 minus 9 also gets cancelled here, and 36 minus 16 becomes 20. Okay, so cancelling the like terms which with the different signs and simplifying it. Okay, so I'll erase this so that you should not get confused while cancelling. Okay, so cancelling the terms, after cancelling and subtraction we get this step. Then what can I take common in this? I can take 4 common, so remains 3x plus y minus 5, and 4 goes in the denominator here. This should be 0 by 4, not 0 by 5. Okay, okay, so 0 by 4, anyway it becomes 0. This should be 0 by 4. Three x plus y minus 5 is equals to 0 by 4, and that is 0. So finally the relation between x and y is 3x plus y minus 5. You have to solve it very carefully by applying the formula a minus b whole square, expanding it and cancelling the terms which are getting cancelled. So the relation between x and y comes out to be 3x plus y minus 5. So this is the way we solve different questions using distance formula. Okay, and you need a lot of practice